Okay, good afternoon, everyone. Welcome to this my YouTube channel. This is Baraga Baradum, and this is Mass Mastering Academy. I welcome you all for this YouTube channel. Let's look at what is before us today. We are looking at how to find the derivative of functions from first principle, and it's very important. This is in calculus. How to find the derivative of a function from first principle. You need to know that before you can be able to solve anything or to find any derivative by first principle in calculus, you must understand the standard of it. So let's look at how to get the formula first of first principle. Let's say you assume let y equals to f of x. If x increases by the x, then y will have a corresponding increase of the y. You know that in calculus talk about the rate of change. That means if x increases, then y will also increase. If x changes, then the corresponding y will also change. So now, from our assumption that we have that let y equals to f of x, now y increased by dy. This dy means that the increase respect to y. So you add y increased by dy, then here we have f of x. That means x also increased by the x. Now at this point in time, now we want to make this dy to be the subject of the formula. So we subtracted y from both sides because we want this y to be on our right hand side. So we subtract both sides by y. If you subtract both sides by y, you have y plus dy minus y equals to f of x plus the x minus y here also on our right hand side. Now we know that this y, we cancel this y, left with dy, then equals to f of x minus y on our right hand side. But initially we know that our y was equals to f of x. So in this case now, this particular point we are, which is dy equals to f of x plus the x minus y. We know that our y was what? Since initially our y was equals to f of x, you quickly substitute our y with f of x. That is why we have from here dy equals to f of x, that was here, plus the x minus, this is what to be our y, but we know that our y is what? F of x. That's why I put this f of x. Now we divide through by the x because we want this equation to be in a standard form of the y over the x. So we divide through by the x. So here now, this is our dy here, we divide by the x. That's why I have the y dx equals to, here we have f of x plus the x, we divide minus f of x, right? So we divide by the x. That's why I have this the s on our right hand side here. And we know that now for us to get our small letter of the y over the s, which is the gradient of the function, we take the limit as this capital dx tend to 0. The capital, you take the limit of both sides, which is we are going to have the limit of this dy over the x as the s tend to 0 equals to the limit of the whole entire thing we have on the right hand side, which is f of x plus the x minus f of x all over the x that we have here as the x tend to 0. Now as the x tend to 0 here is going to affect this capital dy dx. That's how we got the small letter of dy dx as this capital dx tend to 0. So we are left with the limit of f of x plus the x minus f of x all over the x as the x tend to 0. And this is the basic formula for first principle. This is the formula we use in solving first principle. So just take note of this formula because we are going to use to solve example. Okay, let's look at example 1. They say that we should use the method of first principle to find the derivative of y with respect to x when y equals to x plus 3. We should use the method of what? First principle to find the derivative of y with respect to x when y equals to x plus 3. We know that the formula that we have in the first principle when we try to find out was dy over the x equals to the limit of f of x plus the x minus f of x all over the x as the x tend to 0. So we're going to use that formula to solve this. Now solution: if y equals to x plus 3, To find the derivative, it also mean what? Dy over the x. To find the derivative of y with respect to x is as following. This is the question that they give us: y equals to x plus 3. Now, by the method of first principle, we know that when y increase by the x, this the x mean that increase in y, that you add plus dy, this dy rather, this dy mean increase in y. When y increase by dy, then equals to our x here increase by the x, then we add plus the x, then plus our constant 3 that we have here. Now after that, we want this dy to be on its own, to be the subject of the formula. So because of that, we subtract both sides by y. So we have y plus dy minus y equals to, on our right hand side we have x plus the x, right, plus 3, then we subtract it by the minus y. You know that this y, we cancel this y when subtracting, so we are going to have left here with dy, right, dy, then equals to x plus the x plus 3 that we have on our right hand side minus the y. Now recall that before we have our y from the question, our y was what? X plus 3. So from here now we know that minus y, so we replace that x plus 3 in place of this our y. So we replace x plus 3. If I have here x plus 3, but this x plus 3 now, you need to take note of it. You need to put it in bracket, because if you just put x plus 3, you're not going to get the final answer. So you need to put it in bracket so that when expanding it, you can get the actual answer. So now our dy over our dy here equals to what? X plus the x plus 3 minus bracket x plus 3, because we replace this x plus 3 in place of our y, because our y was equals to x plus 3 from the given question. Now our dy now equals to x plus the x that we have here plus 3 minus, now we expand this, minus times x going to give us minus x, minus times plus y going to give us minus times plus 3 going to give us minus 3. Now we know that this x here, we cancel this minus x, and this 3 here, we cancel this minus 3. So we are left with what? The x here on our right hand side. So our dy becoming equals to the x. Now we divide both sides by the x, because we want our left hand side here to be in dy over the x. So when we divide by the x, we have dy over the x on our left hand side equals to the x over the x, because we have the x already on our right hand side. So you see divided by the x. Now we have the x dx. It implies that our dy dx equals to what? 1, because the x go into the x 1 time, so you have 1 here. So now what we are going to do now is that, now we know that our dy over the x equals to 1, right? Now we take the limit of both sides. We take the limit of both sides as the x tend to 0. Okay, now we take the limit of both sides as the x tend to 0. So if we take the limit of our left hand side, we have the limit of dy over the x as the x tend to 0 equals to, we take the limit of our right hand side, which is limit of 1 as the x tend to 0. You know that the limit of this dy over the x that is in a capital letter as the x tend to 0 is going to affect it to become small letter of dy over the x, which is our major gradient, equals to, now we know that we don't have the x on our right hand side, it's only 1, so there's nothing to substitute in place of this 0. So because of only 1 we have here, we put equals to 1. So our dy over the x equals to 1, and this is our final answer, and that is the final answer of it from the given question that we have. So thank you very much. Okay, let's continue. Let's look at the second example of how to find the derivative of a function using the method of first principle. Let's look at example 2. They say you should find dy over the x if y equals to x squared plus 3x plus 2 by using the method of first principle. Look at the solution. Y equals to x squared plus 3x plus 2. This is the question that they gave us. First, we're able to find the derivative of this function, which is dy over the x, by first principle. You know that when y increase by dy, that's why I say y plus dy. You know that in calculus, if y increase, the corresponding x will also increase. So that's why I have this y here plus dy. This dy means change in y. So equals to x here. This x, we have this x plus the x, that is change in x. You know that there was square on top of the x, that's why I put this square here, plus this 3 x, you put the s in bracket, change in s, you had which is plus the x, change in this x, s plus the x plus 2. Now we come down, y plus the y on the left hand side equals to, no, this x plus the x is raised to a power 2, that's why we just put it in x plus the x times x plus the x, the same thing as x plus the x square plus 3x plus the s plus 2. We have y plus the y on our left hand side equals to, if you expand this, we are going to have x times s is s square times x plus x times the x, going to give us x the s. You come to this side plus the x times x, going to give us x the x, the x times the x, going to give us the s square plus 3 times x, going to give us 3x plus 3 times the x, going to give us plus 3 the s plus these two that we have at this end. Then y plus dy equals to x square plus x the s plus x the s is going to give us 2x the x plus the s square here plus 3x plus 3 the x plus 2. Now, so remember that what we have was y plus dy on our left hand side equals to x square plus 2x the x plus the x square plus 3x plus 3 the x plus 2 recently. Now we make this y to come on the right hand side because we wanted the s to be on its own. So the s now, by subtracting y from both sides, if you subtract y minus y, you're going to have the y. When this y cross the corrective sign, you're going to give us, you see, have on our right hand side x square plus 2x the x plus the s square plus 3x plus 3 the x plus 2. When this y come to this side, become minus y, and you know that you have the y on our left hand side equals to x square plus 2x the x plus the x square plus 3x plus 3 the x plus 2 on our right hand side, subtracted by, you know that this x square plus 3x plus 2 represent our y, because initially our y was equal to x square plus 3x plus 2 in our equation, but because of that we put it in a bracket so that it can be able to know how to expand it. Now on the left hand side I have the y equals to x square plus 2x dx plus the x square plus 3x plus 3 dx plus 2 minus times x square going to give us minus x square minus times 3x going to give us minus 3x minus times plus 2 going to give us minus 2. Now you know that x square here, this x square, we cancel this x square here. We know that this 3x, this 3 here minus 3, we cancel it, and these 2 that we have here minus 2, we cancel it. That's why we are left with the y on our left hand side equals to 2 dx plus the x square plus 3 dx here. Now we divide both sides by the x to make it be in the form of the y dx. So we are going to have on our left hand side divide over the x equals to, you know that on the right hand side we have 2x dx divided by the x plus here we have the x square, we divide by the x plus here we have 3 dx, we divide by the x, because we are dividing each of them by the x. On the left hand side we still have the y dx equals to, you know that this dx, we cancel this dx here, and we know that this is the x square divided by the x, we're going to remain with 1 dx plus, you know that this dx here, we cancel this dx remaining by 3. Now we take the limit of both sides as the x tend to 0, so that's why I have the limit of the y over the x as the x tend to 0. We take the limit of this 2s to us, which is a limit of 2x as the x tend to 0 plus the limit of the x as the x tend to 0 plus the limit of 3 as the x tend to 0. Now you know that this the x now as it tend to 0 is going to affect this capital the x to the y over the s equals to, no, now that you know that you now have the x here, so we still have 2s because there is no the s to substitute 0, so we have 2s plus here we have the x, so this the x now turn to 0 because this represents the x turn to 0. Then plus here we don't have anything like the x, so it's just 3, so we put plus 3. So therefore our dy over the x equals to 2x plus 3, and this is our final answer by first principle. If you have any question, you can drop it on the comment section. And if you are not subscribed, try to subscribe. Thank you very much. Like the video and share it. God bless you.